On this episode of This Week in Space, we're going to talk about the year that was in space 2022 and what to expect for 2023. Stay with us.
Podcasts you love.
From people you trust.
This is TWiT.
This is This Week in Space, episode number 43, recorded January 6, 2023. 2022 in space. Hey everybody, it's time for the TWiT Audience Survey. The annual survey helps us understand our audience so we can make your listening experience even better. It only takes a few minutes. Go to twit.tv/survey23. That's twit.tv/survey23 to take it. Don't wait. The last day to take the survey is January 31st. Thanks from us. Hello and welcome to another episode of This Week in Space, the what was in 2022 and what will be in 2023 edition. I'm Rod Pyle, editor-in-chief of Astro Magazine. I'm joined by the unflappable Tariq Malik, editor-in-chief of space.com. Happy New Year, my friend.
Happy New Year, Rod. Happy New Year, listeners. It's going to be another good year in space. It was a great year last year. Hopefully this will be an even better year. So
let's have a Starship year this year, shall we?
Yeah.
Wouldn't that be nice?
An amazing space tourism year without any private rocket explosions. That'd be great too. So.
Okay. Well, yeah. Before we stroll through last year and the next, I'm sorry to say I have, yes, a space joke. This one from listener Jan Wild. Yes,
it's the first one. It's the first one of the year, so we need like a lot of fanfare for it. I've missed these.
Okay, you ready?
Yes, I'm ready.
How does the man in the moon cut his hair?
How, Rod? How does the man in the moon cut his hair?
Eclipse it.
Hey, we're going to talk about that this year. That's great.
Yeah, well, see, timely. That was first of the year. So come on, don't be the last one to send us a new joke, audience. Join Team Tariq and send us a groaner. Or if you want to join Team Pyle Driver, you can send us a good joke. All right.
He said Pyle Driver. That's awesome.
Well, that was supposed to be my pilot name if I joined the Air Force, but for reasons that anybody who ever sees video of this will be able to tell, there's good reasons I'm not a pilot. All right. At least we keep you amused for about 30 seconds on Fridays. So do us a solid and be sure, additionally, to like, subscribe, and all that cool podcast stuff. After all, we're free. So let's do some headlines, shall we? We haven't done headlines for a couple of weeks, and it's time. We're overdue.
And I know that many of our listeners might have had the holidays off, but it turns out space did not, for reasons we're going to talk about.
Oh, man. So we got a leaky Soyuz on the space station, and we talked about that a couple of weeks ago. And that means that the coolant streamed out, for those who may not remember. A small hole, still of indeterminate origin, in the Soyuz, which is docked at the space station, which stays there generally 4 to 6 months at a time. And without coolant, it probably shouldn't be used for reentry. Now, I did hear at one point that the Russians had advised NASA, hey, you better be prepared to roll the space station a bit to keep it in the shade so the electronics don't cook and all that stuff. I don't know that happened, but we've got a Soyuz up there baking away, and we've got a SpaceX capsule, which means we can bring home half the people on the space station. So you have a story from space.com about what might be planned to make sure that we get people back if there's a problem up there.
Yeah, this is really interesting because the last week of the year, actually Reuters had a really interesting piece where they got NASA on the record to say that, they were thinking about SpaceX and seeing what SpaceX could do. And then late last week, so just as we were coming into the new year, NASA put out an official update. And this is the fact, it acknowledges that NASA has actually reached out to SpaceX and asked them, what could they do in terms of a crew rescue scenario? Do they have a spare Dragon ready to go to basically serve as a return ship for these two cosmonauts, NASA astronaut Frank Rubio and two cosmonauts on the space station? Now, at the last check, NASA hasn't said if they've heard back from SpaceX or not. But SpaceX is getting ready on February 19th to launch their next astronaut crew to the space station. So you could see a scenario where if NASA and Russia really feel like they need it, SpaceX could say, hey, Crew 6, which includes a Russian cosmonaut, no, we're not going to launch you. We're going to launch it automatically because SpaceX can do that with their Dragons. And we'll include some maybe generic flight suits and stuff like that for the 3 astronauts. Maybe they send 1 astronaut on the ship. Now that would be unprecedented for SpaceX, but that's the scenario that is being looked at right now, because the Soyuz that is up there, the stricken Soyuz, it was an exterior coolant loop that lost all of its coolant. You know, it's somewhere around 70, 80 degrees inside all the time. Not too bad, but pretty hot if you're stuck in there over time. And it takes about 6 to 8 hours for them to get back from the space station on a good reentry day. They were supposed to come back in March, you know, around mid-March or so on this Soyuz. And the earliest Russia has said that they could get a Soyuz, a new one, to the station, like there's a new crew that's supposed to be going up to relieve them, would be February. And it would require a lot of rejiggering about how does it get up there? How do they fly it autonomously or not? And so, you know, you've got these 2 ships that may or may not be ready to fly, a SpaceX's Dragon and a Soyuz in February. Clearly, it doesn't seem like anyone can get up there for January, but we're just trying to wait and see like what is possible for this. In the meantime, that's about all we're getting. NASA has been putting out these updates Fridays at 6:00. We might get one on this recording day tonight and learn a little bit more about what's happening. But Roscosmos, Russia's space agency, did say that January, so this month, is the month that they're going to make a decision one way or another to, you know, plead for SpaceX for help to launch a Soyuz early. They're going to make it this month. It's still not a lot of refined you know, a schedule for what we're going to get, but at least they're pinning it down that they're going to have to take some action soon.
So I've only been in a very early version of the Crew Dragon, but it was originally designed to be able to take up to 7 people if you had the crew couches in there. And there was some postulation online from people who may or may not have been qualified to be talking about it. I'm certainly not. That you could put additional astronauts on the back floor depending on how it was configured for that flight. And I haven't seen anything about that since this first story broke. There was also some talk about the fact that the original Dragon capsule was at one point intended to carry crew, and that, you know, one of those could be configured, but that's probably as much trouble as finishing a Crew Dragon early. But do you know anything about the former?
It's interesting about the 7-person crew, because that was an early requirement of the commercial crew program, both not just for SpaceX, but for Starliner, for anyone that applied. It was supposed to have that capability, and they reduced it down to 4 so that they could add a lot of cargo, a lot of supplies. The kind of limiting factors for the Dragon that's up there right now is it's supposed to come back a lot later. It's not going to be coming back in February. It'll be coming back a bit later in the year. B, they have to wear these special SpaceX flight suits, and they don't have those right now for the 3 crew members of the Soyuz. That may not be the most limiting of factors, but then you have the factor in that they've designed this flight and all of its consumables for a 4-person crew, not for 7. So what's the excess capability that they could have there, and then what's the space capability? Like, they'll need to bring down as much stuff as they can for those 3 crew members, in addition to what they have to already bring down for the 4 crew members there. So, you know, there's a bit of a numbers game there about, can you fit them in? Can you bring the existing crew home early for when this crew is supposed to rotate out in March or not? And is that acceptable to kind of have that excess capacity? I think, you know, if push comes to shove, they could probably get comfortable with it if they really had to do it, because they know that spacecraft works, and they know that the Soyuz spacecraft may not work. But right now, they're really trying to see what they can do with the Soyuz situation now. Maybe they'll surprise us and they'll decide they can fix this coolant thing. I doubt that's going to happen. But, you know, when Russia was having ballistic reentries, Soyuz landing after Soyuz landing after Soyuz landing, they eventually sent the cosmonaut crew outside with a hacksaw and cut off an antenna which was interfering with the signals during landing and forcing the capsules onto ballistic reentries. That kind of fix was crazy. They cut into the exterior thermal blankets of the Soyuz to get to that gear, and yet it did go off swimmingly. And Sergei Volkov, the cosmonaut commander, and his crew were able to come down on a normal trajectory. So that kind of fix could be possible. They would still need coolant to refresh the system, and if they can do that in space, I'm not sure. But there's still a lot of unanswered questions. It's good they have this SpaceX cruise ship there that was originally designed to hold 7. Can it hold 7 now? Open question being looked at right now. Could they use the existing Dragon that's getting ready to launch next month? Certainly they could, if they can get comfortable with the flight suit situation and the training. But that spacecraft is designed to be highly automated, and so I think SpaceX would be comfortable, trying that out.
Well, here's my dream scenario, and I'll send a letter off as soon as we're done to the Boeing Public Relations Department. Boeing gets their next Starliner ready early, and they build adapters for Soyuz spacesuits and SpaceX spacesuits so that they can hook into the environmental loop and all that other stuff they have to do, radio communications and so forth, if that's still hardwired. And Boeing saves the day and sends up the Starliner early, and there you go. Problem solved, and they come off looking like roses, but they already look pretty good after Artemis 1. All right, moving on. Praise from Moscow. Rare praise from the new chief of Roscosmos, which is something we're certainly not used to, right?
Yeah. You found this story, right, from the Moscow Times and AFP, where Borisov, right, the head of of Roscosmos, was saying that NASA and that cooperation has been going well as they try to figure out what to do about this whole thing. It is kind of refreshing to see that after the year we've had of Russia U.S. relations.
Well, and Rogozin for all those years. Ride your brooms to your rockets, you losers.
But don't forget about the trampoline, right?
Yeah, trampoline.
Oh man. But this was really, I mean, I hadn't seen this story until you had brought it up, and this Moscow Times story that you found, where they have him saying, say hello to the entire American team, and they've been very worthy, in this situation. And while he hopes that Russia will manage on their own, it's they're taking comfort to know that this bipartisan approach to safety in space is underway. And this is a story, Rod, that you and I have talked about a lot this year, or last year, pardon me, with the war in Ukraine and whatnot, and kind of how the space station program endured despite all of the issues. And we saw with Rogozin, there was a lot of bluster. We saw some of that creep into space with the cosmonauts putting up some flags, some Russian flags and whatnot amid it all. And but it was clear that there's Americans in Moscow working on the space station program. There's Russians in Houston working on the space station program, and they never missed a beat when it came to safeguarding the crews, making sure they have what they need. And I don't think we're going to see any change with what's going on with the Soyuz, the stricken Soyuz right now, and Russia's new space chief, who has really done a lot to dial down that temperature that Rogozin really raised with all of his tempestuous tweets throughout the year, really just seems to be leaning into it. So it's really nice to see that. It's kind of a nice way to end the year. In fact, the day, as we're recording this day right now, it's actually Orthodox Russian Christmas. So they have that day off on the space station, and they're likely spending it together as a crew and enjoying some time off, because they get 2 Christmases in space, which would be nice. I think when we were all kids, we always wanted 2 Christmases. So
when you said tempestuous tweets, you reminded me of Robin in the 1960s Batman. Those are some tempestuous tweets. All right. Wrapping up headlines, we have finally another comet coming around, we think. You never know till they're here, because, of course, it all depends on how they interact with the sun and what kind of a tail we get. But we have Comet C 2022 E3 parentheses ZTF in parentheses. Tell us all about it.
That's right. This is a comet. This is really exciting because, we last year we were kind of in a drought when it came to comets. And prior to that, there was a comet Lovejoy that we were all hoping was going to be an amazing thing. This is the first potentially naked eye object like comet of 2023, and it doesn't really have its like a nickname that we can call it yet. I mean, we could call it Zwicky. The Zwicky Telescope Facility is the one that found it in I believe it's Hawaii. It was discovered in like the spring or that kind of transition period of 2021, and at that time, even then, they knew it was going to come early this year, and it could be a target to watch. And since July, amateur astronomers have been tracking it as it kind of made its way to the inner solar system. And on January 13th, it will make its closest approach to the sun. Then it's going to start flipping back out. But one of the really interesting things that this is the first time this comet has come back into the inner solar system in 50,000 years. So there were maybe Neanderthals might have been able to see it way back when, and we're not going to see it, for that same amount of time as it goes back around back into the Oort cloud. It is in the northeastern sky, before dawn. NASA has some guides. NASA JPL has some guides about where to see it. We have some, of course, on space.com, and we're going to have kind of blanket coverage of this comet as it comes in, because it's kind of a 1-2 punch. While it does get brighter in the sky as it makes its closest approach to the sun on January 13th, it will keep getting closer to Earth into early February. February 2nd, I believe, is when it's closest to Earth. Still many million miles away, but it does mean that it's a tantalizing target that we hope will become visible to the unaided eye. You will need dark skies. That's the one thing that I always have to caution people for this. If you're getting up at dawn, you want to get up at dawn in a remote place that doesn't have a lot of city lights, street lights, aren't going to cut it. Even a dark park where I am in northern New Jersey, there was some bleed over from the parking lot some distance behind us, and it was hard to see the comets back in 2020. So this is something to watch. We've got a couple of weeks to see if it does get brighter or not. Now, your human eye, you need to see. Astronomers have a scale called magnitude that they use to gauge the brightness of things, and the lower the number, the better it is. And the negative numbers are really, really great. But the limit to what the human eye can see is a magnitude 6, usually six or so. And Venus, by the way, is like a magnitude -2, -3. It's really bright in the night sky. So we're hoping it'll get into those negative numbers, and then we can see it really brightly. But time's going to tell. So let's hope. Let's hope for good things, and that doesn't get obliterated as it swings around the sun. I don't think it's going to get that close, but that does happen for some sun grazing comets, and we'll know later this month. So maybe we'll have an update, as we get to Earth approach, to let you know how it goes.
Well, and I live in Southern California, so for the last comet, whose name I forget, but it was about a year and a half ago. I was in San Diego at the time, and I had to drive probably 2.5, 3 hours to get somewhere dark enough that if I squinted with binoculars, I could actually see it. So wherever you are, I would suggest going to darksky.org. That is a website, darksky.org, and it'll tell you where the nearest dark sky site to you is. And given how America's wired these days for lighting, it's probably very far away.
And you brought up a really good point too. Just before we go, you brought up a really good point about binoculars, because if you go out without binoculars, your chances are kind of, maybe you'll see it, maybe you won't, but you should be able to see it with binoculars if you know where to look. And so having those as a backup would be really good to have, even if you don't have a telescope. So,
but don't buy the $10 binoculars on Amazon. Get good ones. Let's talk about 2022.
Yeah, so, new year. Out with the old, in with the new.
Yeah, but what an old year. So the thing that got my attention, and I think we agreed on this, is SpaceX just knocked it out of the park. Now we've got Elon Musk a little distracted with Twitter, which is irritating to some of us, but the guy should do what he's going to do because he is wealthy, and wealthy people get to do what they want to do. But what a spectacular year for them. 61 launches, more than double the rate of the previous year.
Oh, almost double. Almost double. They launched 31 in 2021.
Oh, so that would have been 62. Okay.
And 61. Yeah, just shy. I think you can give
nits,
it to
will you? but that brings them to a total Falcon 9 successful launches of close to 200.
Oh, they've hit that. They actually have already they just launched their first mission of this week of 2023, and so now they are at 200. Yeah.
So see, this is what happens when you work on a quarterly. You're late on all these things. And almost matched everything launched out of the entirety of China, which was 64.
Yeah.
Is that right? Yeah.
Yeah.
So that's a lot. And this is one company that really, I mean, for any faults that we might want to mention about Mr. Musk himself, I mean, they have revolutionized launch. They have revolutionized maybe not rocketry, but the technology, certainly of flight pace and reuse. And we've got one booster. I think the total count now is 15 reuses. Is the record, right?
Yeah. In fact, they just flew another one. The one that their first launch of 2023 was another 15-time flyer. So it's not just a fluke that they've gotten one of their boosters that were originally designed for 10 flights to 15. They've done it twice now. They're going to keep flying these really veterans to kind of push the limit, I believe, in 2023, just to see, because Elon has said, oh, maybe we could fly one of them 100 times, and just to put that in perspective, most of the space shuttles, there were 135 space shuttles and
space shuttle
flights. Would be nice if there were 135 space shuttles. Yeah,
we'd be broke. No, you don't want to service
but they all flew, 20, 25, maybe 30 times. There might have been one. I remember they're all,
but with extensive. I mean, they were almost, at least in the aft end, almost virtually rebuilt.
That's right. I mean, there was substantial. So here we are at the 15 mark for a lot of these flights. And SpaceX, they did fly a Falcon Heavy launch in 2021, their first, or 2022, their first in 3 years. And they've got plans for at least another one of those. And of course, they've got Starship. Now, we've been talking about Starship for the last few years. They did not have a test flight in 2022, despite everything that we had been expecting. A lot of they kind of closed strong with a lot of engine firings, but they were a lot of delays. We talked about this before too, that they've been trying to work on. And they've built a new tower at Launch Pad 39A, where it's behind, but you can't miss it because it's nearly double the size of the Crew Dragon launch pad there, to as a backup to launch Starship from there. So there's a lot that they did in 2022 that was amazing. Now they had some obstacles. Right now they've got some slower Starlink speeds as of now than when they first launched it, and so they're working to kind of get the rates of that back up. And Starlink,
you're talking about transmission speeds?
The transmission speeds, yeah.
Launch rate. Yeah.
Not the launch rate. The launch rate itself has been gone really well. You haven't heard a lot of the people about the astronomers complaining about the fleet size and the light pollution, although that's still in the background, and SpaceX says that they're still trying to address that. There's newcomers that launched in 2022 that have even bigger satellites with constellations that are raising eyebrows. So I think SpaceX has less heat on it for that. But this year they're working to try to increase that, not just the rate of their Starlink launches, because they launched a lot of them, but they also got approval to launch 4,000 more. And so we'll probably see a higher pace of those missions, and SpaceX working to increase the speed for that, because Starlink is their cash cow to finance everything else for SpaceX's company, or at least they've said that in the past. The big question, you mentioned Elon Musk and his distraction at Twitter. He did buy Twitter. A lot of non-space Twitter news with Elon.
I think this audience knows that. Yes.
That's right. So we still are going to want to see how that turns out. Now, actually, at a recent press conference, Bill Nelson was asked, the NASA chief was asked about the distractions for that. But I think they said that he's talked with Gwen Shotwell at SpaceX, the president, and they're fine. There's no distractions there.
Well, which is exactly what I'd say if I had a contract with NASA, but
that's right.
I think she's probably telling the truth. Okay. And since we talked about China earlier, let's rock over to China. They completed their latest Tiangong space station, which is a little confusing because they're calling them all the same thing. So we had Tiangong 1, which was not a whole lot larger than the upper stage of a rocket. So they were pretty cramped in there. Then they had Tiangong 2, which is another single module station. And now we've got Tiangong 3, which is a modular station like the ISS is. Um, Looks to be about a third the usable volume of the ISS, and yet they're quoting it for 6 astronauts. So I imagine that's pretty compact living. But if you've ever spent time in Shanghai, like some of us have, you know that people do live a more compact lifestyle there. So maybe that's okay. So they got a core module. I think two experimental modules launched now. So that's a total of 3, and maybe expanded to 6 ultimately. One thing I thought was interesting about the story, then I'll turn over to you, was they have also affixed Hall thrusters, ion engines to this thing, in addition to the chemical rockets, which are what we use, of course, on the ISS to change orbits and change orientation if there's debris coming by and so forth. And this, to some observers, all from here, of course, because the Chinese don't talk a lot about what they're doing sometimes, talks towards an ultimate idea of using those in cislunar space and possibly out to Mars. One of the this really blew me away. One of the ion thrusters that they use on that space station, the design had been tested for over 8,200 hours.
Wow.
Which would easily be enough for a round trip to Mars at those speeds, because these things, of course, thrust continuously. So rather than having this big chemical blast and expending your fuel, they expend their fuel much more slowly and can thrust continuously for obviously very long periods of time. So I thought that was interesting. But of course, there's a lot more of the story of the Chinese station than that, right?
Yeah, so China is, just to put it into comparison with the International Space Station. The International Space Station is about the size of a football field, American football field, I should say. A lot of people play soccer and call it football, and that's fine.
You mean the real football? Yeah.
That's right. But the space station's about 100 tons. China's space station's about 60 tons. It's got 3 main modules. You got that core module. You have these 2 others that are docked on the side, so it looks like a giant T. T stands for Tariq, I'm sure. But but then you've got,
of course.
Then you've got, like, they have an automated cargo ship, very similar to the ATVs that Europe built. So these great big modules themselves, and then they have their Shenzhou spacecraft. So what they've done is they've completed the kind of like the core version of the space station, and they've now rotated a couple of crews out in 2022, and they've set the stage for what may be a continuous crewed presence for the foreseeable future. One of the things I'm looking forward to this year, because it seems like that's all gone really well. They've tested a robotic arm. They've done some spacewalks. Another female astronaut spacewalk was one among their milestones this year. They'll be celebrating another Chinese New Year in space with the crew. And so in the next few weeks, but they may launch a new space telescope. And this is the really interesting thing that I was looking for, because China has said that they might add more modules, like you mentioned, maybe 6 or so over time to build out this station. But they've got this new space telescope that they would launch into like an orbit near Tiangong. Right. And it would do stuff like, look at the cosmos, just basically it's a Hubble Space Telescope class observatory. And then when they want to add stuff to it, or they want to refurbish it, it would rendezvous with the space station and dock, and then they would do it there. Now that's crazy, cool. And it would be really neat to see. And so that's supposed to launch near the end of the year, in the last quarter or so of the year. And what we've seen now is a foothold in space of China's space program, and you could see them open up to additional foreign partners where we talked about. They've been training astronauts for different countries. They've been working with the European Space Agency. There's some, there's not a lot of hope for close cooperation with NASA because of just restrictions, but definitely, they've got this core foothold in space. They had this high launch rate, 64 missions in 2022. You could see a lot of that coming up now. And we did hear from Space News, actually, that they're reporting that China is now looking at opening their spaceport, their core one for crew launches in Wangqian, the island, and Hainan Island, to commercial and private launches as well. That will be something to watch, because that could really boost the use of this space station beyond just core national space program needs.
Now, you say commercial launches, you're talking about the semi-commercial companies they have working in their space sector, or international cargo going up?
And the semi commercial ones that they've got going on right now, basically it's kind of the model that NASA has opened up at KSC, where they're leasing out pads and whatnot, because Wangcheng is the primary launch site for the big rockets that support the Tiangong space station and the crewed flights themselves.
Well, I bet your dinner conversations are interesting at home. Does your family glaze over when you start talking about this stuff? Mine does.
Oh yeah, all the eyeballs roll back pretty.
I got
quickly.
30 seconds into it. They're like, "Oh, Dad, please." All right. Well, an 800-pound gorilla just walked into the room, and his name is the James Webb Space Telescope. We need to talk about that, because what an achievement! What a year with that. It seems like we're racking up a new farthest galaxy every couple of months, which, we're getting dangerously close to the Big Bang. Look at these things. Now, I say dangerously close, still well over 180 million years, but nonetheless, that's pretty close to the very beginning of everything.
So if I had to pick, go ahead.
I was just going to say some of the early things they did. I mean, we all saw that first release of imagery.
Mm-hmm.
A little quieter after that. They evaluated an exoplanet, spotted water in the atmosphere. Later, they spotted another one that had carbon dioxide, which are things they're looking for, because, of course, carbon dioxide can mean other things relevant to life. Then moved to looking at getting some high-res imagery of stuff in the solar system, including Jupiter, which is one of the things they wanted to prove out, because they wanted to be able to track nearby moving objects, which is not easy. Of course, the running list of galaxies, as I mentioned. Looked at the rings of Neptune, looked at the early universe details from galaxy MAC S067-JD. We really need to start naming these things Fred,
We'll call it, Bob.
And excitingly, something that a lot of us really were waiting for with bated breath was that early look at the TRAPPIST-1 exoplanet system, where we've got, I think, 7 exoplanets, of which a number are in the so-called habitable zone. Now, of course, they're a lot closer to their star than we are to ours, because it's a cooler star. But that's cool. And then finally, and I'll toss this to you in a second, because I know you're going to have details about these things. More detail about the water plumes on Enceladus, Saturn's moon, which, of course, is exciting to us, because that is a further indication of a warm ocean below, squirting all this water up onto the surface. What, among other things, what the Webb saw is that they're global in nature, at least in terms of the atmospheric effect they have. And everything is working well beyond what was expected. The only real worries that I've read about, you may have seen more, was this higher incidence of micrometeorite and impactite damage that they've been seeing. And finally, there has been some grumbling in the science community about limited funding available from NASA for analysis of all the data they're getting back, because they're getting seriously backlogged.
Yeah. No, if I had to pick one mission, one thing in space that was the clear standout for 2022, it would be the James Webb Space Telescope. Long delayed, much over budget, launched on Christmas in 2020, and so 2020 and 2021, pardon me. So on 2022, that was its first year in space, and in that first year, it not only deployed perfectly, like this 100+ deployment events, all of these things that had to go perfectly, and it took weeks to get it done. But it checked out, perfectly in July of 2022. We saw those first amazing photos. They just got better and better. It was kind of weird to see the images roll out, not from NASA or the Space Telescope Science Institute, but from scientists themselves that were processing the images as they were coming out to make these. I mean, my favorite by far is this. There's this image of the Phantom Galaxy that was created from the James Webb data, and it looks like one of those 3D pictures where, like, you can see, I don't know, like a space shuttle hidden amongst all the other things that comes out over time. Those puzzle images. It looked like one of those. It's just absolutely spectacular. But it has been surprising. I mean, just about how smooth it's gone. In fact, this month is the American Astronomical Society meeting. The very first press conference they will have on January 9th will be all about James Webb Space Telescope and what it's been doing. Not just that, but the call will be going out for new studies. What else to look at, for the second round of observations. Now you mentioned the funding for the analysis. That is going to be an issue going forward. In a way, it's a bit of a good thing to have because it means you have a lot of data to go through.
If you're going to have a problem, that's the one you want, right?
But the micrometeor damage was interesting. And in fact, Webb did see some power glitches in late November, early December too. This is something they're going to want to watch because this is a first of its kind telescope. It's the biggest ever sent in space. It's this, massive 21 feet across. And so they're going to have to see how this stands up over time. And there is some discussions that we kind of built the hardest space telescope to build of the next gens ones with James Webb, and that future ones that have been called for with astronomical studies might even be easier to build. And we might want to keep them in like a serviceable design to go up and update them like we did with Hubble.
Right.
And at the same time this is going on, NASA has actually put out a call for ideas to go up and service the Hubble Space Telescope and keep it lasting a little bit longer. That came out in late December. The SpaceX has kind of floated this idea because Jared Isaacman, the private Polaris project guy, kind of wants to go up and offer like a free servicing mission. But if they're able to do that and have Webb up there for a lot longer overlapping with Hubble, then what these scientists are going to get from James Webb is going to be immeasurable because they will have had this longer baseline to compare with Hubble. So that'll be interesting to see. Hubble's birthday is in April of this year, the 33rd birthday. So we'll see if, how things are going. Hubble's getting a bit old and creaky. So.
Well, and you mentioned Isaacman. So the Polaris Dawn project is 3 or 4 flights that he's going to pay for in association with do them in association with SpaceX. For a private guy to say, hey, by the way, while I'm out there, do you want me to go over and do something with the Hubble? And the last I read on that was they were talking about primarily about boosting it to a higher orbit so it can stay viable. Servicing would be a little more complicated because it's got a grappling pin, but that's not the same as what the shuttle was able to do because the shuttle had an arm. So that might be a little tougher, although you'd think they could do it with a tether. But, imagine if they went up there and actually did servicing in terms of changing out modules and gyroscopes and so forth. But even if it's just repositioned, quote, just repositioned, that's a very big deal. Now, what I'm hoping for, of course, and it's interesting, NASA's completely invested in Starship for the crewed lunar landing, and yet has not, that I've seen anyway, really become invested in the idea of, hey, we can launch, if it's configured properly, we can launch much larger space telescopes in this thing that don't have to have, I think on Webb, it was 470 separate mechanical events, which were never tested in 0G, as I pointed out before. They were all tested on Earth at 1G. So if you do that, not only do you have to not worry about all these mass constraints, but mechanically, from an engineering standpoint, it becomes much simpler to deploy these large instruments, even if they're in modules that end up getting assembled.
So it'll be interesting to see. Now, you're right to point out that the private the private pitch is to reboost only. I think I misspoke earlier. I might have called it servicing, but yeah, it is reboost only at this point in time. Just giving it a bit nudge up that will extend the life probably for 5-10 years if they can get it up there, as long as nothing else breaks. So, yeah, right. Yeah. All right. We've got a couple more missions at least, I think, to talk about, right? We've got DART, we've got Artemis 1. We got a lot of stuff.
We sort of we're kind of shoving that down the list, but it's kind of a big deal. But I did want before we got too lost, I wanted to mention the end of the Mars Insight mission because that was something that a lot of people were watching. This was a static lander that was designed to study the size, thickness, and density of the Martian crust and the structure of the core and mantle by using a seismograph and a heat flow experiment. And the seismograph worked brilliantly. The heat flow experiment did not work so well. That was the self-hammering probe, otherwise known as the mole. The mole. That was supposed to go down into maybe up to 6 feet down the Martian soil and got, 6 or 7 inches and then got hung up. And they never were able to get that to work. But the seismograph was a very cool experiment. And it wasn't the first one. Viking had them as well back in the 70s. But they were attached to the frame of the lander, and recorded more wind blowing by than they did actual seismic events, we think. And only one of them worked. The other one, a pin got hung up and it didn't uncage itself from the landing sequence. So the one on InSight was a very weird kind of Rube Goldbergish looking sort of arrangement, flew on the top of the lander deck and then was picked up by a robotic arm and stuck down the surface, but worked brilliantly and recorded somewhere in the neighborhood of 1,300 Mars quakes, some of them rather large, which is Jim Green, I think, told both of us when we talked to him. He was the chief scientist at NASA headquarters at the time. Is something critical for eventually sending crews to Mars, because you want to know, if we're talking about building in lava pits and caves and so forth, you want to know how much rock is going to come shaking down their heads if you've got a seismically active planet. And it turns out we do have a seismically active planet, which also brings up some interesting conversations about possible dynamics of existing volcanism, maybe, although we haven't seen any sign of that, like big plumes coming out of the volcanoes or anything. But there might still be some activity going on in a planet that we thought was mostly geologically dead. So that was pretty exciting. Well, that mission came to an end late in the year. Too much dust on the solar panels. And the first question that gets asked, of course, by a lot of people is, why doesn't NASA come up with a way to clean the solar panels? And there's two answers. One is it's mechanically very complicated and expensive to do, and these missions are already expensive. And two, they've discovered, really, I think since Pathfinder, which was the first rover back in the 90s, that these self-cleaning events come along. We've got a little dust devil, it'll go strolling by, and it will whisk the dust off the solar panels. That did not happen here, at least not enough. And they even tried with the robotic arm lifting up some heavier grit, some sand, and sprinkling that nearby and hoping that would scrape off some of the dust, but it just wasn't enough. And sadly, at the end of the year, it went out of contact. Now, my understanding from JPL is that although they've declared the mission over 2 years later, which, is still a respectable length of time, that they will be checking in every now and then to see if there's any chance that it went into standby mode, and if there is a cleaning event, which of course they won't be able to see because they'll only be able to spot it from orbit. But if there is a cleaning event that comes along and it does recharge itself and the batteries are still viable and it survives the cold Martian nighttime temperatures, that it might start transmitting again. So fingers crossed for that.
Yeah, it is winter on Mars now, which is a little bit more challenging in terms of like the conditions on the spacecraft. Now, that the method that you mentioned where they would sprinkle some dirt on the solar arrays and then the wind would blow that off and kind of create streaks of cleanness. They did that a few times actually during the mission overall, and it worked earlier. It just for this last try, it just did not work. And we had gotten clues as early as February of 2021 from NASA that the end was nigh for InSight, that the power levels were getting low.
Right.
In fact, they had said that by May of 2021, it was going to be, too weak to do science. That went until well into the summer, actually, and then they just kind of kept going as long as they could until December. Of course, they finally announced that it had gone silent and it was likely for good. I would point out that even until the end, that seismometer was built, generating science, and they did confirm that they detected the biggest Mars quake ever in like the final month of the mission, and it dwarfed everything else that it had seen. And so it just goes to show you that up until the end, these machines are just, they can just do amazing science. We should probably talk about Artemis 1 right now.
Wait, no, not yet. One more. I want to talk about DART because I was so excited about DART. So this is a double asteroid redirection test. The idea was to use a spacecraft as a kinetic impactor to divert a small asteroid moonlet that was orbiting another asteroid. And so the asteroid was Didymos and Dimorphos was the moon. Moon's about, I think, 500 feet across. Is that right? And then the other one's in the range of 2,500 or something. So, they picked a small target, but this was an audacious mission. I mean, you're basically designing something the size of a golf cart, not very massive, to go up, but hit this at great speed, which of course imparts a lot of energy, and see what happens. So what a success. Not only did it work, but it changed the orbital period of Didymos much more than expected, 33 minutes. And I was wondering why. And of course, we had one of the science leads for that mission on the show a couple of months ago. They had hoped for, I think, maybe 8 or 10 minutes, but it was explained to me that because the impact displaced more mass than they expected, about 2 million pounds of rock, that besides the energy imparted directly into the object, that actually had a propulsive effect.
That's right.
And helped move this thing further than expected. So we now have at least a toehold in what we need to do to divert something like an asteroid or a comet, hopefully not the one that's coming by this year, away from Earth, as long as you get it early enough. Now, obviously, they're going to have to scale this up or scale up other methods to do this if there's a large, really dangerous rock coming. But this was a big deal, and it was incredibly successful for what it was.
It was amazing. This is actually one of the few events in space that I was actually at the event when it was going on. I did go to Artemis 1, of course, for the first couple launch tries, and just was not able to go for the final one. But I mean, the excitement level was palpable at Johns Hopkins University, where they run this mission from, and it was amazing. I mean, it was a bullseye impact. It succeeded in changing the orbital speed much more than they thought, and it just kind of proved out a lot of concept on how we could protect our planet from potentially dangerous asteroids, as long as we've got the time and the effort to look and find them in the first place. That is step one for this. I think that also kind of emboldened NASA a little bit to look at other ways that they might want to go test, and maybe more affordable ways. This was a fairly affordable mission compared to some of the bigger asteroid missions they've sent in the past. So we'll see how that goes. And the science is still coming. In fact, there was an announcement just earlier where they say that they think that the asteroid Dimorphos is a little bit like an M&M from the images that they got in the the waning minutes of the impacts live there. So and we expect more to come out of it from additional studies about exactly what it was. What does that tell us about, not just how we can protect our planet, but what these things are, these dregs left over from the formation of our solar system, and what it might mean for other solar systems that are out there as well.
Well, and you bring up a very good point, which is we have to spot these things before we can divert them with any method. And it is a little bit of a head scratcher to me. We've been working on the NEO Surveyor mission, the Near Earth Object Surveyor mission, in one form or another for 12 years, I think, at least. It's been proposed, it's been pushed back, it's been proposed, it's been delayed, it's been proposed, it's been underfunded. And now it's moving ahead, but it's still struggling to get full support. And this is an orbiting telescope that would be able to spot these objects, not just better than most ground telescopes, but also something that we can't do well from Earth, which is spot them closer to the sun, where every now and then one of these things just comes hurtling out of the blackness, and we go, hey, look, that's going to swing by Earth in about 10 minutes. I'm exaggerating. But, you need to spot them first. And this is a critical first step. So do you know anything more about why this has been such a slow roll for the NEO Surveyor?
Well, it's there's design in there. They are making steps to start building the craft now. I mean, it's a matter of funding and making sure that they get it set. Rod, then that funding took a long time to get into place for the mission, and there was a lot of back and forth about whether or not it was going to make it all the way through. This type of planetary defense, planetary awareness, for what's out there, was kind of shortlisted in recent astronomy surveys. So we know that was a priority, but it was really trying to get the funding for it to get it all the way through. And they finally were able to get it, and now they're making progress on it now. Whether or not they get, again, I should point out, there were other efforts to get private versions of this up. And in fact, some of them are still underway too, to get a private satellite to look for these kinds of things too. But, Bill Nelson has said that this will be a critical tool in NASA's belt and in the world's, really, to kind of find a lot of these near Earth asteroids that we don't see because they come out from the direction of the sun, where we just can't look with telescopes that we've got. That's what this is going to excel at when it gets up there.
Okay, so I see you bouncing up and down in your chair, which means it's time to talk about Artemis 1. So I just give this one to you. It was cool. It worked. Boeing's happy. We're happy. Everybody's happy. Take it away.
It was, so I said that James Webb was like the best thing of the year. I'm going to stand by that, but a very close second would be Artemis 1. And the difference there is that James Webb is looking at the, beginning of our universe and everything that we see. Artemis 1 is the future of humanity in space, at least for NASA right now. And we gave it a lot of flack. We have to kind of own up to that this year, Rod. We kind of gave Artemis 1 the short shrift.
I think that was you.
All right. Yes, I did. Ever since the Project Constellation, with the very early version of what evolved into the SLS, was announced in 2004, I had been waiting for this giant rocket.
Excuse me, we should point out, announced in 2004 and died on the shores of other NASA programs that were flown only in file cabinets around 2010. So yeah, that didn't go so well. That's right. And so what is that? That's 18 years of waiting for this new rocket. Orion been around since then. Even did its own test flight on a Delta IV Heavy way back when. So I had very low expectations. I admit that, right? I just did not think it was going to work. I was dubious it was going to get off the ground. I owe everybody at thespace.com Girl Scout cookies because of it, because I told them that it was not going to fly. I get a chair and they get Girl Scout cookies. That's pretty lame.
That's okay. Right. I'll send you some too, Rod. Don't worry.
Thank you.
But it was just amazing how flawless it appeared to go. Now, there were some glitches. There were some power things. They lost contact with the Orion spacecraft for a bit in deep space, but it wasn't anything that was mission critical, which is really, really surprising. They had very clear views of the splashdown, and it had landed in its upright position out in the Pacific Ocean. That was really promising to see. And now the Orion capsule is back in Florida, where it can undergo a really thorough analysis to see how the heat shield performed. But by all accounts, it seems to have done extremely well. This was a 2-week mission, and it was long on purpose. The actual crewed flights are going to be a lot shorter, maybe like a week, maybe 10 days. Actually, no, pardon me. It was a 20-day mission or so, and so we got just amazing views. Our first close-up views of the moon from a crew-capable spacecraft in forever that set a new record for the longest distance from Earth of a crew-capable spacecraft since Apollo 13. No astronauts on this, but it kind of really put a feather in NASA's cap, in Lockheed Martin's cap for the spacecraft, the Orion spacecraft itself, in Boeing's cap for the performance of the SLS, and Northrop Grumman, who built the boosters, the 5-segment boosters. And it also, I should point out, a lot of the stuff on this mission was direct heritage stuff from the space shuttle program, the main engines. The engine on Orion was an Ohm's engine, on the solid rocket, from the shuttle years, and it was never designed to fly around the moon, and yet it did just fine. So a lot of proving out that those concepts, that we can still squeeze more life out of the shuttle hardware, even though we don't have one, and NASA has now renewed contracts to build more of that stuff. And so I'll eat my hat. I was very skeptical the mission was going to get off the ground. I was skeptical that it was going to be fine. It was both. It was, much more than what NASA had expected, and kind of how smooth it went. And we had near real-time live video almost the entire time, all the way out to the moon and back, for the most part. And NASA did finally spin up a live feed from the spacecraft because people just wanted to check in and see. And we got those amazing selfie views of the spacecraft as it approached the moon. It got bigger and bigger in the window, in the frame, and then coming back, and we saw Earth from so far away. It was just an amazing kind of end of the year for spaceflight. So, I mean, my hat's off to that whole team about how well that went. I hope they had a nice holiday break because it did land just before Christmas. And now it's on to Artemis 2, that first crewed space launch coming in 2024. And we'll see how NASA gets there. So,
well, and we can use that as our pivot to 2023, which will be our lightning round. But I have to add one more cool thing about the Artemis 1 mission. They had, as you know, a special self-contained version of Amazon's Alexa, which we say for people that may have it in their home that don't want to have it be triggered by what I'm saying, on board. So the astronauts could say, hey, In this case, it was called Callisto. Hey, Callisto, what's the fuel level? Hey, Callisto, abort. Hopefully that wasn't in there. But it also, they invited people, they being Lockheed Martin, invited people to send in messages that would be displayed on that panel, which is right in front of the astronaut seated position, and would be on camera. And I sent a little space haiku, and millions of other people sent things. But my favorite one came when they were at that furthest distance, which I think was, 8 or 10,000 miles further out than Apollo 13's high altitude record past the moon, which said, hey, we're calling about your spacecraft warranty. We want to offer you a renewal. And I thought that was pretty cute. And they let that one go by because, of course, these were being reviewed. So let's talk about, let's start with that. So in 2024, we're supposed to have Artemis 2. However, the reason, now let's just step back for a second. Once Apollo was up and running, as Jerry Griffin was talking about in our last episode, once Apollo was running, you were flying these things as often as every 2 months. Why this long delay before the next one? Well, one of the reasons is they had decided years ago, as an apparent cost-cutting measure, to refly the avionics from the Orion in the next Orion capsule, which now looks like kind of a questionable decision, right?
Well, no, NASA has committed to only flying one Orion mission a year once they get up and running with this, because they're just multi-billion-dollar mission. I think it's like $2 billion a flight right now, is what they're looking at. So well, there you go,
my friend.
Yeah. I was lowballing it. So
hey,
if
you
they're
should
only
be a
going to do
contractor.
Only if it's cost plus, Rod. Only if it's cost plus.
Yeah, right.
But with that kind of a time frame, they want to use as much as they can. I mean, originally they wanted to reuse all of Orion, just like SpaceX does with its capsules. But,
right.
But there's heat shield issues. There's the fact that it lands in the water, that sort of thing. But they think they can pull out a lot of the interior hardware to use, and they're going to use some of the flight boxes for Artemis 2. So, and they want to study it, and what changes do they need to make for Artemis 2? That's what's going to take this whole year to kind of get through. Really check the spacecraft. So that once they get rolling,
have people on it.
That's right.
Which
they
is
need to finish.
Change, yeah.
They need to finish the life support, because this mission did not have all of that.
Okay. All right. So I'm going to give this to you as a lightning round, because we have a number of things we want to talk about. But 2023 is chock full of new stuff. Before I release, though, SpaceX, of course, is going to do the orbital test of Starship, and I'm guessing it's going to be June or later. So I'd like to make the following bet with you. Okay. If I win, we trade jobs and paychecks, and I get to go run space.com, and you get to come work on my magazine and do public relations at the National Space Society and write books for not very much money. What do you think?
So well, you know what? I'll in spirit, I will shake your hand on that bet. I'm going to say April, just because that's my birthday month. I think that they could probably get it done by then. So okay. I'll say April.
And if you win, we'll change jobs, and I'll take your paycheck, and you'll come work on the magazine. Okay.
If I win, you will pull all your string. If I win, you'll pull your strings and get a way for me to hug a hippo at the LA Zoo. How about that? There.
Yeah, you're weirder than I thought. All right.
I love hippos. All right. So
okay,
let's go. Okay, really fast. Things to look forward to in 2023. The first rocket lab launch from U.S. soil, that's going to come from Virginia. I'm going to drive down to that to see that Electron fly. Then we do have maybe the first Vulcan Centaur launch from ULA. That's going to carry a private moon lander, the Peregrine 1 mission. So that'll be something to look at, because that's a brand new mission. It's going to have Blue Origin's new engine on it. Some new strap-on boosters from Northrop Grumman. Europe and NASA, they're launching the JUICE mission to Jupiter in April. Again, my birthday month.
And that is Jupiter Icy Moons Explorer. Just so people know what we're talking about here.
Gonna go check out
orbit Ganymede, Callisto, and Europa. Right, first orbits of moons outside of ours by any spacecraft, not just flybys.
Very exciting. We got a lot of missions to the moon. Intuitive Machines launching their moon lander on a SpaceX flight. Japan is launching their SLIM moon lander. We talked about Peregrine 1 launching on the Vulcan Centaur. China maybe launching some new Chang'e missions. We've got Chandrayaan 3 from India launching in the summer, and maybe Russia is finally going to get the Luna 25 lander off the ground in April. So lots of things to watch there. In March, SpaceX will launch the Polaris Dawn mission, the first of 3 missions bankrolled by billionaire Jared Isaacman. That's going to have the first private spacewalk ever. So we're going to hopefully see how that goes. And we talked about Starship already. Later in the summer, NASA is launching the Psyche asteroid mission to not 1, not 2, not 3, but many asteroids. They did have to cut one off because they've been delayed a year because of software issues, but we're really looking forward to that. India, meanwhile, may launch 1, if not more, uncrewed tests of its Gangayaan crewed spacecraft system. We're looking forward to that. It has been delayed, but they do want to launch their first astronaut on their homegrown rockets in the next year or 2. Boeing. We didn't talk about Boeing in our roundup, but Boeing finally launched an uncrewed trip to the space station with Starliner, and their first crewed trip could be later this year in April or so. So we're going to be looking forward to that. NASA's OSIRIS-REx asteroid probe will bring back samples of the Bennu asteroid in the summer, I believe in September. So keep an eye out. And if you are in the United States and you love solar eclipses like I do, mark your calendars for October 14th. October 14th is a annular Ring of Fire solar eclipse. It will be visible from U.S. soil, from many national parks, actually, and it's going to be amazing across the U.S. Southwest, and it is going to be the one to see. So, I mean, that's just October. There's stuff happening in November and December too, but there's a lot of stuff happening. That's the tip of the iceberg. We haven't talked about space tourism. Maybe those flights are going to start getting off the ground. Virgin Galactic, Blue Origin, bouncing back from their lost uncrewed rocket last year. So I'm excited. I'm excited about that. Plus, we're going to get a lot of new discoveries from the existing space telescopes that we've got now too.
Okay, I'm out of breath and I didn't even have to do it. So I want to thank everyone for joining us today. Sorry we had to wrap up so quick, but we'll be talking a lot more about 2023, of course, as we see it coming. We had a heck of a year in 2022, and this is going to be an amazing year. So stay with us, and we'll keep you up to speed on everything. Tariq, remind us, where can people track your amazing life?
Well, they can find me at space.com, as always, on Twitter at Tariq J. Malik, and hopefully seeing this comet before it slips my grasp for the next 50,000 years. So we're going to keep looking up for that.
You're pretty healthy, but that would be asking a lot. All right. And you can, of course, spy on me at pylebooks.com, pylebooks.com, or at astromagazine.com. Also on Facebook, Twitter, and occasionally Instagram. Don't forget to drop us a line at twit.tv. That's TWIS at twit.tv. We welcome your comments, suggestions, ideas, and jokes, just as a reminder. And we love getting all of them, and we answer every single email. Be sure to join us next week. New episodes published every Friday on your favorite podcatcher. So please subscribe, tell your friends, give us reviews. Multiple thumbs up, 5 stars, whatever they've got. And you can always head to our website for the show at twit.tv/TWIS. Don't forget, you can get all the great programming on the TWiT network ad-free on Club TWiT, as well as some extras that are only available there for just $7 a month. And that's a heck of a bargain no matter how you look at it. You can also follow the TWiT Tech Podcast Network at TWiT on Twitter and on Facebook, and twit.tv on Instagram. We'll see you next time. Thanks, everybody.
If you are looking for a midweek update on the week's tech news, I got to tell you, you got to check out Tech News Weekly. See, it's all kind of built in there with the title. You get to learn about the news in tech that matters. Every Thursday, Jason Howell and I talk to the people making and breaking the tech news, get their insights and their interesting stories. It's a great show to check out, twit.tv/TNW.